Welcome to the Fast Mode podcast series. I'm Tara Neil, and with me today is Kalyan Sundhar, Vice President and General Manager of Network Access, Keysight Commercial Communications Group. Keysight is an S&P 500 technology company headquartered in Santa Rosa, California, with offices and manufacturing worldwide. Its customers span the communications, industrial automation, aerospace and defense, automotive, energy, semiconductor, and general electronics market. Kalyan is a wireless industry leader with over 25 years of experience and has created and led the Wireless Edge to Core Product Development Center of Excellence that focused on Keysight's Open RAN suite of products. He is regularly involved in industry events such as delivering keynotes, hosting webinars, participating in panels, etc. He has 9 patents in wireless and is also the co-author of the popular 5G for Dummies book. Kalyan joins us today as part of our exclusive editorial segment on Open RAN. Welcome, Kalyan. Great to have you on today's episode.
Thank you very much, Tara. I'm glad to be here.
So let's start with the basics. How important is testing and validation in Open RAN, and how does it differ from traditional RAN?
It's a very good question. I would say if you look at Open RAN versus the monolithic or traditional RAN, you had everything come from one vendor in the traditional RAN. So a lot of things were internally validated by that vendor. There could be some proprietary interface, some proprietary information, all of that was inside that particular monolith. So validation was only contained to that particular vendor. When you look at Open RAN, you're opening up, disintegrating the network, opening up many interfaces, and as a result, you're bringing player A and player B to work with each other. That is something typically not done in their shops. So it becomes even more vital for testing to come into play, where you're validating whether A and B are first conformant, and second, A and B can interoperate with each other. And third, A and B can actually work to the performance level and have the reliability, security, and so on that are required for it to be deployed in the networks.
So now that we have modularized, a lot of the entire monolithic solution now comes in many modules. So basically you have to repeat these 3 steps that you just said across every module separately. And that is where it becomes far more complex than, the predecessor stack.
Absolutely. It's a necessary step, and testing becomes very vital in doing this, because you need first an independent body like Keysight provides with tools and techniques there. And second, you got to make sure that A can play with not just B, but with any C, D, or E. Similarly, B can play with any other combination. So the testing also multiplies a bit, because now you're making sure that multiple of these pairings can work with each other.
And when you have the results, can you pinpoint where the issue lies? For example, if it involves like 2-3 components across 2-3 vendors, is it easy to pinpoint, or do you need to do a lot of follow-up testing in a lab environment and stuff?
It's not so much follow-up testing, but it's isolating and pinpointing where the issues are. And this is harder, right? Because you're bringing in 2 different vendors into play, and easily it could be, the finger could be pointed the other way. So it is vital that you provide the necessary information. It's not like you have a lot of opportunities to go retest, but it's very important when you test, you collect all the necessary data, you do the analytics on that and say, well, look, looks like these packets that I've laid, and this is why we believe so. So there has got to be a bit more, built into the whole testing methodology itself, where you're extracting the information and also analyzing the information, and then you're in a better position to say where the issue is. Is it easy? No, absolutely, it's not easy. It's definitely more work, but you don't repeat the work. You do it the first time. You do it right the first time.
And also because Open RAN introduces completely new components like OCUs, ODUs. So do we need to establish new protocols for testing because these are new elements, as well as now we have like APIs testing, and then we have the open interfaces and stuff. So do you have to like come up with new, new KPIs for this components that were not there before?
Yeah, so there is speciality between each of these interfaces. For
Mm-hmm.
example, there is a lot of emphasis right now on the
Mm-hmm.
interface between the radio unit and the DU or DU plus CU.
Mm-hmm.
It
Mm-hmm.
could be, it's called the front hall. And
Mm-hmm.
there is tremendous amount of emphasis going on into the front hall validation.
Mm-hmm.
To address your question on are there, it's another interface. So from the
Mm-hmm.
perspective of interfaces, it is very similar, but you're also zeroing in because now you got to make sure it's not a proprietary interface, it is a standard interface, and how the different components adhere to it.
Mm-hmm. Do you do any security kind of testing?
Absolutely, because security now that the vulnerability is a lot higher because you're opening
Mm-hmm.
up the network even more. So there are
Mm-hmm.
more points where a security attacker could come in. So there is
Mm-hmm.
and there's a lot of Ethernet interfaces in
Mm-hmm.
addition to the RF interfaces. So you are exposed. The threat surfaces have increased as a result. So
Mm-hmm.
there is a lot more opportunity for getting into the network and having some malicious attacks. So it
Mm-hmm.
is very vital for us to have a very secure and thorough testing going on across the RAN to the core of the network.
Mm-hmm. And do CSPs also come to you guys to see if they are compliant with certain requirements, like say, for example, zero trust architecture requirements? Do you guys go in and see whether this current architecture complies to that?
Absolutely, absolutely. There is a lot of that there, and there is also specific 3GPP and ORAN
Mm-hmm.
Alliance
Yeah. Mm-hmm.
protocols that have been
Mm-hmm.
defined, test cases that have been defined. Some of those are mandatory, some of those are optional, and eventually
Mm-hmm.
they will also be required. So there is a lot of work going on in terms of security, and definitely people, CSPs and others come in with the requests that you're talking about.
All right. Okay. So that when you have the results, right, how is it incorporated into the network? How is it used to enhance the network?
Yeah, so automation becomes first a very vital factor, right? So as an example, in the pre-Open RAN days, you would typically see an upgrade once every, I mean, 6 months is a short time. It could be even longer than that because you are really bringing in big components into the network, big upgrades that go on.
Mm-hmm.
In Open RAN, you're selectively upgrading each component, and there could be multiple upgrades even on a weekly basis where you are trying to upgrade the radio or the firmware, or a specific component in the DU. These are all very possible. As the result, you have first a lot of testing that has to go on and that has to be repeated.
Mm-hmm.
So the way to incorporate this and what we have seen is these results feed into a common framework. Sometimes the CSPs provide that. We also provide frameworks that we can
Mm-hmm.
attach to the overall automation frameworks. And
Mm-hmm.
then there is some analytics that is put in place to see whether that particular combination of software loads and hardwares can be deployed. And if
Mm-hmm.
there is any issue there, you back off quickly. So there are mechanisms in place to go rapidly. So the learning that you're putting in place through the testing is very quickly put in place into the production side and vice versa. So from the production, you can pull it back into the lab. So in an ideal situation, you
Mm-hmm.
want to be able to selectively upgrade and downgrade builds as
Mm-hmm.
quickly as possible. And the
Mm-hmm.
mechanisms are in place in many cases, and in some cases, it's coming up.
All right. So when you do testing and validation, do you have like a 1-0 result, or does it go like in grades, like just like exam grades?
Yeah, so the 1-0 results are where you have very clear specifications saying that you shall do this much of
Mm-hmm.
throughput,
Mm-hmm.
or the
Mm-hmm.
errors cannot be beyond this.
Mm-hmm.
We also have shades of gray where the CSPs can come in and say these particular tests we can give an allowance of 2% errors as an example. or one and so many. So there are cases where you have the ability for the CSPs to define what the pass fail criteria is. The 0 or 1 ultimately is the pass fail criteria. Of course, what is always required is more so when you fail, why you're failing. So the data behind what happened in the network is very vital, so the corrective measures can be taken after that.
Oh, so I think it's quite a complex process, although, it's just a simple, people say, well, we are just testing the network, but the processes that are involved, we can appreciate that. And one other thing, what about the frequency? Do you just go in when there's a new solution that's being deployed or integrated, or is there like a milestone, like every 6 months you guys go in and do a report for your clients?
Yeah, no, it's continuous, and there are cases. For example, through the NTIA, there were some common labs funded in North America, and this is also there worldwide, where you call the Open RAN Integration and Test Centers called OTICs. So what happens in here is there is continuous work going on where a particular pairing of vendors could come in, vendor A and vendor B, and we validate that, and that happens year round. So there is continuous validation, there's certification that goes along with it. You get a certificate when you are conformant. You get a badge when you actually interoperate, but it goes beyond that. The test cases are that's the basics to some extent. You go
Yes.
even beyond that, saying, are you meeting the performance that is required for you to get into this particular operator's network? And the operators are defining those minimum criteria for a vendor to come in. So those validations are happening year round as well. So there is, I would say, continuous activity, literally 25/7, if I may say that goes on in the network right now.
Wow, amazing. So can you tell us more about Keysight's solutions for Open RAN testing?
Absolutely. So Keysight looked at this as a great opportunity, not just from a test and measurement vendor perspective, but from an ecosystem perspective, where we could see this come in the 2019 timeframe, where when Open RAN was formed, and many operators were behind this. I mean, the key thing to emphasize is this is an alliance and initiative that was formed by the operators themselves, because they wanted the best of the breed vendors to come in. They wanted to be able to upgrade the network when they wanted to, and in a piecemeal fashion. They didn't have to do a holistic thing. They can just change the radios, they can just change the network. So there were many things that were coming in from that perspective. So I think from that perspective, Keysight saw this early in 2019 or so, and then we have been we're one of the few companies that have end-to-end portfolio all the way from the edge of the network to the core of the network. We call it the CORA, the Keysight Open RAN Architect portfolio, and we have everything from validating the radios, the chipsets that go into radios, and then the ecosystem, so the devices, the chipsets on the radio side. Then you go into the and you look at new concepts like massive MIMO, beamforming, and all that, which improves your throughput and so on. And then you get into more and more of the core side of the network, finishing the RAN, going into the core. So it's an end-to-end portfolio, and pretty much we simulate every part of the network. So you can bring in a real device, a real node, replace it with Keysight, and we will be able to provide an end-to-end solution. So we do have everything from the device side all the way to the core side of the network.
Wow. And in Keysight's experience over the years, which area within, say, for example, 5G or 4G that's most difficult to test and validate?
Yeah, so each area goes through its life cycles. I would say the challenge in 5G and specifically Open RAN is in the front haul, because now you're separating out the radio from the baseband units, which was the one of the key thrusts going in. And I think that work is largely underway. There's a lot of activity going on there, and that will continue to go on. So that's a challenging area, because a lot of times you didn't know the radio could have been an OEM for the monolith, and now they have to operate with different radios, and radios come in from multiple
Yep.
parts of
Yep.
the world. So there's just a plethora of that. So that is a challenging one. And then the second one I would say is just the concept of virtualizing the baseband and beyond. Because there you're trying to go from a purpose-built hardware into a common hardware solution, and there you're also having multi-tenants where you have
Yep.
your piece and then
Exactly.
somebody else is putting their piece. So there's a lot of cloudification, virtualizations coming into the picture there. So there are some challenges there as well, in terms of capacity and in terms of interoperability and so on. So there are definitely, it's groundbreaking. There are many things that go on in parallel. So we do see different types of challenges in the different areas of the network.
You just mentioned about the new stack which involves virtualization. So and the use of cloud, right? So does it mean that some of your testing will now be testing IT components like the cloud, see whether the cloud responds in time? Because we have now gone into basically out of this monolithic stack, proprietary devices. So what's your take on that?
Absolutely. And the good news there is some of this has happened before. Like, for example, in other industries, they've already taken things that were on premise going into the cloud and into virtualized environments. And it doesn't even have to be the cloud, meaning public cloud, it could be the private cloud, hybrid
Yep,
cloud,
yep.
etc. So that initiative and that movement started long back. So we do piggyback on that. The core network, for the last 10 plus years has been getting virtualized and cloudified. So that's also happened starting 2011, 2012 timeframe. So now it's the turn of the RAN. So some of those learnings are definitely passed on to the RAN because they're very similar. There are different challenges here because very strict timing criteria, latency, etc., that you need to adhere to. So there are cases where you absolutely need to ensure that some of these components and processes get maximum time share of the process. So there's techniques there. I mean, this is again reusing what's already there, but some things that are much more stringent when you cloudify across the network.
Absolutely. Okay, so there's one last point that we wanted to talk about, which is AI, right? AI is AI, Gen AI. So, and then what comes with AI and Gen AI is obviously automation. So, with automation now becoming like a main theme in Open RAN and RAN in general. So, how does testing and validation change?
It's changing dramatically and very quickly. Clearly, AI is here to stay. And I can tell you that there's something called AI RAN Alliance that is already formed in the last MWC, and in 1 year it has picked up steam quite a bit. The way they are looking at it is there are three different parts of the AI RAN. If you look at it that way, AI RAN Alliance compartmentalizes into AI and RAN, where you're having both AI workloads and RAN
And RAN
workloads
workloads.
running. And then it's AI on RAN, where you're really trying to see what kind of improvements and efficiencies you can build in. For example, how you make the edge more, what do you move to the edge, etc. So the AI on RAN is the next concept, and then AI for RAN is the third one, and that's going to be even more interesting because now you're really building AI into the RAN,
Yeah.
components. So the all three are progressing, and there is lots of activities, experiments going on, and it is moving pretty rapidly. It does tie back into automation and
Yeah.
a closed loop feedback for sure. That is a must where you're really trying to see if it took me 2 months to validate this, how can I, using the analytics and AI and training models that you can put in place, how can I bring this to fruition a lot sooner? And that's a reality that's already happening, and lots of techniques are being applied there. But I think it gets even more interesting as you see how you can apply AI across things like the baseband itself, how
Yeah.
you can make the processing much smarter. So that is the AI for RAN that is going on, and that is the evolution path all the way from 5G, 5G advanced to 6G, and we already started seeing incorporation of that coming in. So it's a definite play. It's starting to happen. Like I said, I shouldn't say easier one, but the one that's already happening clearly is the how do you use AI in the automation frameworks. That's very much in play right now.
Wow, definitely a lot of rapid changes in this space. But with that, we have somehow come to the end of our podcast session. So thank you so much, Kalyan, for joining us today and for sharing all your insights on Open RAN and validation testing and all the complexities and how you guys tackle it. Thank you so much.
Thank you. It's been a pleasure talking to you. Thank you.
All right. Okay. And to everyone tuning in, thank you for listening. If you guys want to learn more, visit www.keysight.com and follow us for more updates and insights as we continue to uncover the latest in technology and telecommunications. See you in our next session. Bye-bye.